Hi there. I want to talk to you about ducts. Well, not really. I've just always wanted to open a video that way. But I do want to talk to you about something related to moving the air in your home. Something that comes from the past and has been written off as mostly obsolete. But I think that's wrong. I think we could apply what we know today to make something better that we forgot about the day before yesterday. What am I babbling about? This is a whole house fan. It ventilates, well, the whole house. This particular fan moves 4,700 cubic feet per minute, making it capable of refreshing all of the air in the house up to 15 times per hour, provided you know how to properly operate one, which I'll get to. To give you an idea of how complex these devices are and how much maintenance is required, this one was installed during construction in 1954, and you're probably not surprised to learn it still moves air. That's because it's not all that complex. There's a big 2-speed motor that has a pulley on its shaft, and the fan blades have a larger pulley so the motor doesn't have to work as hard to turn the blades, especially during startup. The motor may have been replaced at some point, and I'm certain the V-belt has been at least once or twice in the nearly 70 years it's been here, but the carrier bearing for the blades, and in fact the blades themselves, are still doing their job admirably. These aren't common because attic fans are often considered better or more practical in most areas, but I think this is because it has required knowing how to operate a whole house fan properly more than anything else, and that requires some manual labor. Something we don't look kindly upon when simply wanting to be cooler. In order to run the whole house fan properly, you must allow air to come into the house as quickly as the whole house fan draws it out. The necessary airflow coming in is your draft. If you run your whole house fan with too little draft flow, you'll start doing something called backdrafting, and that's not great. You may have heard the term backdraft before, perhaps as the thing that killed those firemen in that movie with Kurt Russell and that other guy no one liked. And that alludes to the same thing, air rushing into an unexpected low-pressure area, except this one doesn't usually result in explosions, that I'm aware of. The backdraft I'm referring to in respect to your house draft comes from your drains. Yes, your drains. In case you didn't know, the thing that prevents your drains from doing that thing you used to do as a kid with a soda straw is this, a standpipe. The standpipe allows displaced air to escape the pipe where you're adding water volume. There's all kinds of neat stuff involved in how drains work, but right now what you need to be aware of is that when water isn't flowing through them, the air stays in the pipe for the kid soda straw reason, with small exceptions we don't care about right now. When water is flowing, the air goes up the standpipe because it's easier to push the air into the thinner air. Just trust me on this. We also care that when you're not draining things, the pipes are empty all the way down to, you guessed it, the sewer connection. In case you're not already putting 2 and 2 together, if you don't allow enough air to come in while you're pulling out air with a giant powerful vent fan, you'll pull the stagnant sewer gas-filled air out of your drains and into your house. Backdraft. You'll never look at Kurt Russell the same again. And now I come back to our manual labor. The way I avoid backdrafting is by opening the windows manually as the sun goes down during the season when it's often hotter outside than in the house during the day, but opposite at night. This is a condition that happens in more regions than we often think of, but I'll get to that later. At the moment, my homemade thermostat will turn on the whole house fan if the temperature outside is more than 3 degrees cooler than the temperature inside when enabled, which leaves us a good window to open the windows. But I could be using it even more efficiently if I had a way to automatically allow enough draft into the house, and I think more people would use them in general. That brings me to these. These are linear actuators. These specific ones are most commonly used in adjustable sofas and beds, so they should have all the pulling and pushing power I need to open large sliding windows. With an 18-inch travel, I'll be able to open several windows pretty far, and the added benefit is that opening the window manually would require fighting the actuator, which is not easy to do. This, in my opinion, is an added dissuasion from imparting shenanigans upon my residence or property. I'm not installing these in this video because they haven't arrived yet, but I will be installing them soon as the season I mentioned earlier is upon us in this region, which is a good segue to talking about where these whole house fans are useful today. Well, simply, they're useful anywhere you want to cool a building by drawing cooler outside air in or want to be able to refresh the air quickly. This is also great for keeping airborne illnesses to a dull roar, something we welcome in this season with our grandchildren going back to school and coming home as inside-out used biohazard containers. Now, you are running the risk of bringing in allergens, which is another thing I'd like to try to address with a filtered vent system. All you need is a large enough hole, or enough smaller holes, in an exterior wall somewhere that you can put a filter or filters into, and voila, the allergen problem can be solved. I will likely sacrifice a few basement windows to create filtered intake channels that I can route to draw air through the entire house, but that's a project for much, much later. Now, I will say there are some regions where the whole house fan will never be a big contender for cooling. In the most humid of regions, the whole house fan isn't your best option because you'll only be pulling in the humid air. So if you don't want the humidity coming in, don't use a whole house fan. But if it's not uncomfortably humid outside and the air is cooler, the whole house fan shines. How much does our whole house fan cost to run? On high, it uses 250 watts. So it costs about 2 cents an hour to run versus the air conditioning that uses much, much more. The air conditioner leaves the air and takes the heat away, but that requires much more energy and also means the house itself isn't cooling as quickly. If you can replace the air for less without bringing in too much unwanted stuff, or you can figure out a filter system, why not do it? They're fairly cheap to install in existing homes, and I think for more modern reasons, it's worth taking a second look at them as a regular option in homes today. In addition, if we taught our thermostats how to control both a whole house fan and dampers for external draft vents, I think we could save a lot more energy during some of the seasons when we typically start using much more than we need to. Anyway, that's all for a later video or videos. I'm hoping this one has given you something to think about, taught you something new about your own home, or been moderately entertaining. If any of those things are true, I implore you to consider bringing your pointer into position with the like button and moving your finger the 1/4 of a centimeter or so it takes to depress the mouse button with aggressive acceleration. Thanks for listening to me ramble, and I do hope you'll join me for future videos as I continue exploring smarter circuits.